Now, let us look into some standard forms of parabola. Generally, the questions that are asked in JEE Mains are based on these standard forms. So first, the standard equation of a parabola is y square equals to 4ax, where of course we know what a is. A is just a constant and x and y are our variables. So if I was to represent this on our graphical scale, so this is our y-axis, this is our x-axis. This is our parabola, where the vertex, this is our vertex. Vertex is at the origin, 0, comma 0. And the directrix will be this line here. The focus will be here, which would be a comma 0. The coordinates of focus would be a comma 0. This is a standard parabola equation. So you need to remember these values. That for any standard parabola, focus is a comma 0. The vertex is at 0 comma 0, and the equation of directrix, since we know that this distance is a, this distance is a, let's say we take the point P here, so the distance of P to focus would be equal to P to the perpendicular distance of this line. So we can write the equation of this line as x equal to minus a, since this point would be minus a comma 0. I hope you are getting the how I'm writing the points. The only thing that you had to remember is that the focus is at a comma 0 and the vertex is at 0 comma 0. After that, you can write down each and everything, since this distance would be a, since it is traveling only in the horizontal line, so there would be no y component here, a, and the distance of course any point on the parabola to the focus would be equal to the foot of perpendicular on the directrix. So this distance also becomes a, and from there we get this point to be minus a comma 0, and this line becomes our x is equals to minus a. So here from this what we can conclude is that the equation of axis of this parabola is y is equals to 0, and the equation of directrix is x is equals to minus a. Our focus is a comma 0, and our vertex is 0 comma 0. So these are some general information that you need to remember. It would be easier for you to solve questions. Now there is one more thing that you can come up with from this equation. Y square is equals to 4ax. Now this 4a, the coefficient of x, which is equal to 4a, this is nothing. Since we know a is a constant, this is nothing but our latus rectum. This is the length of our latus rectum. So our latus rectum would be somewhat like this, since it is perpendicular to the axis and it passes through the focus, and it is a chord, so it intersects the parabola at 2 points. This distance from this point to this point, we are saying that this distance is 4a. So you need to remember the length of latus rectum as well, because it will be easier for you to solve questions. We'll look into a few examples where these concepts have been used so that you can understand why we are trying to learn all this stuff. Now let's look at a few more other standard forms of parabola. Now in this parabola, we know that we call this as a horizontal parabola, and it is right because the face of the parabola we see it is towards facing towards the right. That is why we call it a right horizontal parabola. Now we'll look into other standard forms such as left horizontal parabola, right vertical parabola, and upward vertical parabola and downward vertical parabola. So let's start with the horizontal one. Y square is equal to minus 4ax. Let's say if I write this as the equation, so simply nothing will change. The entire direction of the parabola will be reversed. This is our x-axis, and this would become our parabola. This is our directrix. This is our vertex. which is 0 comma 0. Now this point here becomes a comma 0. So the equation of this directrix becomes x is equals to a. Our focus will be here, which would be minus a comma 0 now. Again, this distance is a, this distance is also a, and the length of latus rectum will remain same for a, since length cannot be negative, of course. So this is our left horizontal parabola. Now let's look at different forms. Let's see if I was to replace x and y. So this would become x square is equals to 4ay. So our parabola would look something like this. This is the directrix. This is the x-axis. This is our axis of parabola. This is our parabola. Here the focus would be somewhere here, and the focus would be 0 comma a. Directrix is this, so its equation would be y is equals to minus a. This point is again 0 comma 0, which is the vertex. And this point here, this would become 0 comma minus a. So this is how we write an upward vertical parabola. Upward vertical parabola. Now if I were to reverse this by using a minus sign, 4ay with a minus sign here, the entire thing would be reversed to downward. This is our x-axis. This becomes the directrix. This is our parabola. This becomes a downward vertical parabola. And we can write down its focus as 0 comma minus a. This point would become 0 comma a. So the equation of directrix would become this would be y. Y is equal to a, and our vertex remains same, which is 0 comma 0. So basically in the standard form, the vertex of our parabola is at the origin 0 comma 0. And again, this distance is a, this also becomes a, and in here as well it was a and a. Again, the length of latus rectum for these two cases is also 4a. So you need to remember whatever is in the single degree term. For example, y here is the single degree term. In this one, x was the single degree term. So the coefficient of the single degree term is our length of latus rectum. Here the latus rectum would be somewhat like this, since it is parallel to the axis. Here the equation of axis would become x is equal to 0, because this is our axis. And how do we write the equation of y-axis? I hope you all know y-axis is written as x is equals to 0, and x-axis is written as y is equals to 0. Just a reminder to you all about this thing. So here in this slide, everything has been given to you in one simple table. This you must remember this table. Horizontal opens right, y is equals to 4ax. So the parabola looks like this, and the vertex is at origin. If you see that in all these standard forms, the vertex is at origin. The axis for this one becomes x-axis, whose equation can be written as y is equals to 0. Focus is at a comma 0. Directrix is at x is equals to minus a. And the length, this is the length of latus rectum, which is 4a. Similarly, for horizontal that opens at left, this is how the graph would look like. Vertical that opens up, and the one that opens down. So you need to remember this. This would help it make easier for you to solve questions and not waste any time solving the general equation and then coming back to the standard form and then trying to solve it. Let's move forward. Let's look at the parametric equations. So in simple words, for y square is equals to 4ax, since this is our standard parabola, the parameters for this can be written as x is equal to at square and y is equal to 2at. So the parameter here is t. I hope you all must have understood. Generally, if you remember, while studying circle, we had studied there comes a theta generally while doing a parametric equation, or while solving straight line, there was a different type of parametric equation. Here it is in the form of a single variable, which is t, so that it becomes easier for you to solve the questions. Now, if I was to check whether these parameters work on the equation or not. Let's just replace the values of x and y in this equation. So what would we get? 2at whole square would be equal to 4a into x is at square. If I open this up, this becomes 4at square and this, sorry, a square t square, and this becomes 4a square t square. Thus, this parameter at least justifies this entire equation. That means our parametric equation, if I was to take up any point p x comma y on a parabola which is y square is equal to 4x, so I can assume that point to be at square comma 2at. Now let's say if I was to reverse, let's say if my equation of parabola was y is equals, sorry, was equal to x square is equals to 4ay. So the parameters would simply just reverse themselves. X will go into y and y will go into x. So my parameters would become 2at comma at square. And let's do one more standard, which is y square is equals to minus 4ax. If this was the condition, then our parameters would have been minus at square comma 2at. Here in this table, you can see all these parameters have been provided to you and you need to remember. I don't think you can remember all these things. If you just remember this one parameter, it will be easier for you to derive all these three parameters. So just remember, if I was to represent a parabola by one single variable t, then it would be any point p x comma y would be equal to p at square comma 2at. This will be used a lot in the questions while we solve, because this makes the entire equation of parabola, which is of two variables x and y, into just a single variable, which is t. Let's look at another standard form where the vertex of the parabola is not at origin. It is at a certain point, let's say v h comma k. So what would the equation of the parabola be then? Let's say this is our directrix, this is our axis, this is our parabola. Here we know it is our focus, and vertex now is at h comma k. But the main thing that we remember from the standard form is that this distance always remains a, and this distance would also remain always a. The distance of parabola and directrix. Do not confuse yourself with this being the y-axis. This is the directrix. So the standard way to write the equation of parabola when vertex h comma k is given, it is y minus k whole square equal to 4a x minus h. This is how the standard way of writing the equation of a parabola with vertex. Now let's try to satisfy this in the previous standard form where h comma k used to be 0 comma 0. If we try to input this value here, then our equation would come out to be y square is equals to 4ax. So definitely this is a standard form, and here the value of a, which is a constant. Let's say if a is greater than 0, a is always positive. Of course, a cannot be 0. Had a been 0, then this would have transformed into some other equation, and this would not be a parabola. This would have transformed into the equation of a quadratic. So let's say if a is always greater than 0, then of course we would get a right facing parabola or an upward facing parabola. And for this, the standard equation would become x minus h whole square, which is equal to 4a y minus k. The vertex is here. Again, we write it as h comma k. So that is how the standard form of vertex works. Here, the same thing has been mentioned. If a is always greater than 0, the parabola would open right, and if a is greater than 0, the parabola would open up. Since this is a vertical parabola, horizontal parabola. Another important thing that you can remember from this chapter, used vastly in questions asked by JEE Mains. Now let's look at this question. This question is again based on the same concepts that we've used. I hope you all remember I had told you that let's say if this is our directrix, this is our parabola, this is our vertex, which is h comma k, and this is our focus. This distance will always remain a because here a has been given to you, and this 4a justifies the length of latus rectum. So now let's look at this question. So a parabola is given. Let us first draw its diagram. The vertex is 2 comma minus 1. And there is a directrix which is 4x minus 3y is equals to 21. And there is a focus here. We do not know what are the points of the focus. So they have asked us what is the length of the latus rectum. So from the standard parabola, so by the look of this, you can say that this is not a standard parabola because the vertex is at h comma k. It is not at some origin. So for standard parabola, where we had studied y square is equal to 4ax, the length of latus rectum used to be 4a. So same thing will be applied here. We know since this is the directrix, this is our parabola. So this distance up till focus would be a, and if this distance is a, this would be also be a. So once we find out this distance of a, then we would be able to find out our length of latus rectum by multiplying it by 4. Now this, you might be thinking that this is the length of latus rectum 4a is of only of standard parabola. No, this length works in all types of parabolas. So if you are able to find out a, you would easily be able to find out the length of latus rectum. So we simply just use our straight line concept of the foot of perpendicular and to find out the distance of a point from a line. So let's say this point is P, this point is M. So our distance PM would be equal to 4x minus 3y minus 21 divided by root under 4 square plus 3 square. Let us simplify this further by inputting the values of P here. So we would get 8 plus 3 minus 2 mod divided by 60. Sorry, this would become 5. And if we solve this even further, we would get 11 minus 2 to be 9 by 5. So we've got the distance PM is equal to 9 by 5. That means our A is equal to 9 by 5. Therefore, our length of latus rectum would be equal to 4A, which is equal to 36 by 5. This is our answer. And this was a question that was asked in JEE Mains. So if you were able to solve it without looking at the video, then I think your concepts of parabola and its equations are very much clear. Now let's look at the parametric equation. Again, there is nothing new here. If you remember, for y square is equal to 4ax, the parameter coordinates that we had studied was 80 square comma 280. The same thing here, when the equation of parabola is y minus k whole square is equals to 4a x minus h. That time our parameters would become h plus 80 square comma k plus 280. If I was to satisfy this here, I have to put h and k equals to 0 comma 0, and you can see that this gets satisfied. That means our parameters that we've chosen are absolutely correct. And similarly for vertical parabola, the things would be reversed. So again, another important thing that you need to remember.
Now let's look at a few important notes that you need to remember on from this chapter, which are based on parabola and its properties. So let's say, again taking our standard parabola, which is y square is equals to 4ax, Let's say this is our parabola. This is our directrix and this is our y-axis. Let's say if I was to take up any 3 points on this parabola. Let's say this is P1, this is P2, and this is P3. So what are the things that you can conclude about these 3 points? First, that all these 3 points would satisfy this equation. If I was to take up the coordinates of P1, P2 and P3, then they would satisfy this equation, which is y square is equal to 4ax. Secondly, the important property is that if I was to join all these 3 points and form a triangle inside the parabola, then the area for this triangle can be found out using this formula that has been given to us. 1 by 8a into modulus of y1 minus y2 into y2 minus y3 into y3 minus y1. Now you could have also found out this using the determinant formula that we had studied in straight line. However, that would make this a bit longer and the calculations would become much intense for you to do it. So this formula is a simplified version for you to find out the area of triangle inscribed in a parabola. Now let's look at some other properties. Distance between vertex and focus is 1 by 4th of latus rectum. I hope you all remember that any parabola, be it a standard parabola or it is not a standard parabola, we can compare it with our standard parabola, which is this one. Y square is equal to 4ax. And we know 4a is the length of our latus rectum. So if I was to draw the diagram for a parabola, let's say this is our parabola. This is my y-axis, this is my x-axis, this is my vertex, here is my focus, and this is my directrix point. So distance between vertex and focus is 1 by 4 of parabola. So is 1 by 4 of latus rectum. So we all know that the focus is a comma 0 if vertex is 0 comma 0. That means this distance is always a. And we know the length of latus rectum is 4a, so this becomes 1 by 4 of latus rectum. So again, important thing to remember. Distance between directrix and latus rectum is half of latus rectum. Again, the same thing. We know that this length is also a. And the distance between directrix and the latus rectum. We know the latus rectum would lie here. It would pass through the focus and is perpendicular to the axis. Our directrix is also perpendicular to the axis. So this distance, what would it be? It would be 2a. So 2a is half of latus rectum, of course. And vertex is the midpoint of the focus and the directrix. So yes, of course, because the distance on both sides is equal, which is a. Now, let me tell you another important property. Let's say we have a standard parabola with vertex at h comma k. So how can we write that parabola? We can write it as y minus k whole square, which would be equal to 4a x minus h. So how, if let's say I was to represent this in the form of a quadratic, how can I write it? I can say x would be equal to some ay square plus by plus c. Now again, a, b and c can be found out by expanding this formula here. But for the time being, I'm assuming that this is our equation of the standard parabola. So from this one, what can we conclude? Firstly, that this is a horizontal parabola. Now again, this concept you can use it while solving graphical representation in quadratics as well. So it can be either right or left. If a is positive, it would be right, and if a is negative, it would be left. Now let's say if I was to take up the vertical parabola and its standard formula. So it would be x minus h whole square would be equal to 4a y minus k. So again, I can write this down in the form of a quadratic as y is equals to ax square plus bx plus c. Now what is this? This is our vertical parabola. and it can be either up or down. And up, it would be up only when a is greater than 0, and down when a is less than 0. So again, this is another thing that you can remember. Whenever in the question they give you parabola in this format, it would be easier for you to calculate the answer.